Hello everyone. Today we will start reviewing Unit 7. Unit 7 it's about material properties. Materials, what do you mean by materials? It's the things that we used in our daily life. So all the materials that we used in our daily life, they are examples of either they are plastic, they are metals, fabrics, wood, pottery, glass, paper, cardboard, and so on. All these materials, okay, we can differentiate between them by their properties. Now, we have two main types of properties. These main types of properties are the physical properties and the chemical properties. Firstly, we will start explaining the physical properties. What do you mean by the word physical or the word physical properties? It means the features of the materials, the features that we can see it, we can feel it, we can touch it. Okay, so the physical properties of a material are the features it possesses that can be investigated by observation or by simple experiment which do not involve chemical reactions. So if you will look at this diagram, here are examples of physical properties. If you will take any material and by asking these questions, you can find the physical properties of it. For example, we will start firstly. Is this material hard or soft? Okay, so when you will be asked about is this material, is it hard or soft? So here you are asking, you are being asked about the physical properties. So another example, the surface appearance, how it is. Is it shiny? Is it dull? Is it rough? Is it smooth? And so on. Then, and it's the same thing for the rest of the examples. Okay. Electrical conductor, is it good or bad? Electrical insulator, is it good or bad? The same thing with heat conductor, heat insulator, waterproof, absorbent, malleable. Okay, can we shape it when you will hammer it? Is it brittle? It means breaks if bent. It's like when you will try to bend it, will it break or no? So all of these are examples of physical properties. We can use it to classify the materials physically. Now, the physical properties of metals and non-metals. As you know, the elements that exist on Earth, all of the elements are classified or are grouped into two groups. These groups are either metals or non-metals. Now, how we can differentiate between metals and non-metals physically, or how we can differentiate between metal and non-metal by their physical properties. Element, definition for element. Elements are substances that are made up of one type of atom. Focus on these two words, one type of atom. Then these elements can be classified into metals and non-metals. Metals, example, iron, copper, silver, gold. And non-metals, example, carbon, sulfur, oxygen, chlorine. Now, if you look at this table, here this table is to differentiate between metal and non-metals by their physical properties. Here this table, the first one, here we have the metals and non-metals and their properties. Let's take the first example, the property as an example. State at room temperature. Okay, any metal that you will bring it at room temperature, which it's 24 or 25 Celsius, you will see it is solid. Okay, except we have mercury, which it's a liquid. Okay, but non-metals, either it could be solid, it could be liquid, or it could be gas. But for metals, you will never find a metal that it's gas at the room temperature. Okay, then density. Metals, they have a higher density than non-metals. Surface metals, they are shiny. Here they are dull. Melting point, high melting point, low melting point, and so on. Usually the main properties that you will be asked about them, they are this one: conduction of heat and electricity, okay, and surface, they are dull, okay, and they are magnetic. These are the main physical properties that you will be asked about it. Here we differentiate between metals and non-metals by their physical properties. But here, how we can differentiate between metal and non-metal by their chemical properties. In chemical properties, here we will focus on, we will see, is this metal, is this element in general, let's say, is it reactive or no? Okay, now we will be able to separate between metals and non-metals by their reactivity. Okay, we will see that usually the metals, most of them are reactive, while non-metals, most of them, they are unreactive, or they react but slowly. Example of reactions, okay, here the reaction between metal and oxygen forms a metal oxide, okay, but when you will have a reaction of non-metal with oxygen, at the same time it will form non-metal, the metal oxide, we call it base. Tips for success: make sure you are familiar with the names of a variety of elements, both metals and non-metals. As you can see, as we mentioned here, the names of elements, okay, here for metals we said iron, copper, silver, gold. For non-metals, carbon, sulfur, oxygen, chlorine, okay, and also you need to know more about the elements, more examples of elements, okay. Here, as you can see here, we have chlorine, copper, helium, iron, oxygen, sulfur, sodium, silver, sodium, and a sulfur. Atoms. When we gave the definition of element, we said element, it's a substance that it's made up of only one type of atom. So what is atom? Atom, it's the smallest unit that in the universe that can exist. So all the elements are made up of atoms. The structure of the atom, it gives the element its physical and chemical properties. So the physical and chemical properties of any substance, it will depend on the atoms. Rutherford and the atom. Rutherford, he was a scientist. He tried to find, or he tried to explain the structure of the atom, and he did a experiment. It was a source of particles, okay, and here we have a foil or a sheet. It's made up of gold, and here behind it there was a screen. So the experiment, how he did it: this source of particles, it sends particles here, and this gold, it's made up of atoms of gold. If we will study the structure of atom, we will see it's in this way, okay. We have this part, then the center we call it nucleus, and this part we call it orbit. So he explained, or he found that when he is sending these particles, what will happen? Most of these particles, it will pass through this gold sheet. So how it passed, or why it passed? Because between nucleus and the orbit, it's empty space. So what happened? These particles, it passed through this empty space. So by this experiment, he explained the structure of the atom. The first 20 elements of the periodic table. In the periodic table, we said it's a table that it contains all the elements that exist on Earth. But these elements are arranged in a unique way, in a specific way, which it's depending on the atomic number or depending on the number of protons. For example, the first one, H, which is hydrogen. Hydrogen, it has 1p. What's that mean? It means one proton. One proton in the nucleus and one electron orbiting the nucleus. Then the second one, helium, He. Okay, He, it has two protons, two neutrons, and two electrons. The third one, lithium, Li, three protons, four neutrons, and three electrons, sorry. Here, if you will focus on all of these atomic structures, you will see that always the number of protons, it's equal to the number of electrons, okay? All the atoms, all the neutral atoms, they have equal number of protons and electrons. Now, the second thing that you should focus on it. Here, we had one electron, so this orbit, we had only one orbit with one electron. Here, we have two electrons on one orbit. But here what happened, the number of electrons, it increased. Now it's 3. Because it's 3, see what happened? We draw two electrons on the first orbit, and the third electron, we draw it on the second orbit. Okay, so what's that mean? It means this orbit, it can carry a specific number of electrons. Now, the first orbit, it can carry up to 2 electrons. It means maximum 2 electrons. Okay, now if we will go to the second orbit, we will see the second orbit, it can carry up to 8. It means maximum we can add 8 electrons. Okay, we will see, for example, this one 10. Okay, now if you will see how many electrons do we have here, 1 2 3 4 5 6 7 8. Now let's move to the next one. 11 protons. That's mean how many electrons also there will be? There will be 11 electrons. Now how we will put this 11? We will draw the first orbit. We can put maximum 2 electrons. 2. How many electrons left? 9. So we will go to the next one. Next one, we can draw maximum 8. Now 2 plus 8, 10. But we have another one. What we will do? We will draw another orbit, and we will put the last one here. So if you will have a question that it says draw an atom, and you will have specific number of protons, so they will give you number of protons. You should know that number of protons is equal to the number of electrons. And how to draw it, how many orbits you will draw, it depends on the number of electrons that you have. Okay, but you need to focus on this first orbit. You can put maximum 2 electrons. The second orbit, you can put maximum 8 electrons. Check your understanding. Also, it will be your task. The periodic table. Periodic table, as we just mentioned, we say periodic table, it's a table that it contains all the elements that exist on Earth. All of these elements are arranged in a specific way depending on their atomic number, or depending on the number of protons. Scientists and the periodic table. The periodic table that we have now, and the one that we are using it now, it's not the only periodic table, or it's not the only way of arranging the elements. Before this periodic table, there was another tables. Okay. For example, there was a scientist. His name was John Dalton. John Dalton, he tried to put all the elements in order using a measurement called atomic weight. Okay. Now we are using the periodic table to arrange elements depending on their atomic number. Okay, this scientist, he was using it, and another scientist, they follow him. Each one, he was trying to arrange these elements in a specific way until we got the version that we are using it now. Here are some examples of scientists and how they use it, how they use the periodic table, or how they arrange the periodic table. This copy of periodic table, it's the one that we are using it now. And as you can see, the squares, each group of square, it has specific color. If you will come here down, you will see each color, it represents something. For example, these two, this first column and the second one, they are reactive metals, and here the green one, they are poor metals, or they are not reactive. Then this periodic tables, it consists, or it's divided into, we call them groups and periods. Okay, it's divided into groups. What do you mean by group? The vertical column, it represents a group. Okay, the vertical columns of the periodic tables, we call them groups. The horizontal lines, or the horizontal rows, we call them periods. Now, here, see, all of these elements, as you can see, they have the same color. But why? We will see why. We have something, we call it trends in groups. If you will come to group number one, we call them alkali metals. Alkali metals, going down the column, it means if we will start from here and we will go down, as much as we will go down, what will happen? The density, it will change. The density of these elements, it will change. When we will go down, their density, it will increase. And at the same time, the melting and boiling point also, it will decrease. Okay, melting point, boiling point, as much as you go down, it will decrease. Okay, when it will decrease, and when the density, it will decrease, what will happen? These metals, when you will go down, it will be softer, and their reactivity, it will increase. Now, if you will have a question, it says, which one is more reactive, this one or this one? So of course it will be this one, because the trends in group number one, it says, as much as you go down, the density, it will increase, the melting point and boiling point, it will decrease, it will be softer, and its reactivity, it will increase. Now, group number two. Group number two, we call it alkaline earth metals. Alkaline earth metals, this is the group number two. Now, what is the trend in this group, in group number two? Going down, the first three elements in this column, the densities, melting points and boiling points decreases, but their reactivity in chemical reaction increase. Okay, also here what's happening, when you will go down, the first three one, the density, the melting point, the boiling point, all of them, it will decrease, but what will happen to the reactivity? The reactivity, it will increase. Then group number seven. Group number seven, this group, we call it halogens. Halogens, going down the column, the melting and boiling point increase, but their reactivity decrease. If you will compare now this one with this one, it's opposite. Here we say it in group number 1 and 2, as much as we go down, the reactivity, it will increase. But here what happened, the reactivity, it will decrease. So this is what do you mean by trends in groups. In groups, we are talking about group, which is a vertical column. Now, trends in periods. Trends in periods, it means, for example, we will take one horizontal row. We will see how it will change, or what is the trend. The trend in periods, moving along each period from group number 2, which is this one, okay, group number 2 to the group number 5, okay, here, let's say this line, this row, okay, what will happen? The elements change from being metal to being non-metals, okay. So now if you have a question, it says at which side the metals locate, you will say that this side, okay. So if you have a question now, it says when you will move from this side, from group number 2, for example, to the group number 5, what is the trend here? You will say we will start with metals, and as long as we move toward group number 5, the elements here, it will be non-metals. Check your understanding, your task. Elements, compounds, and mixtures. Again, definition for element, we said it's a substance that it's made up of only one type of atom. Then, what will happen if atoms, different atoms, join each other? Okay, then it will form a compound. Now, if you want to give a definition for compound, we will say compound is a substance that is formed from 2 or more elements which have joined together as a result of chemical reaction. So compound, to have compound, there should be minimum 2 elements. Minimum 2 elements react with each other, join with each other to form something new. So the physical and chemical properties of a compound are different from physical and chemical properties of the elements which it is formed. For example, let's say let's take an example of hydrogen. Hydrogen, when it's as element, hydrogen as element, it is gas. When it was also oxygen, another example, oxygen, also oxygen, it is gas. Now their physical properties, we will say both of them, they are gases. But when they will react with each other to form a compound, they will form water. Now water, the physical and chemical properties of it differ from the hydrogen and oxygen before they react. A mixture. Mixture, what do you mean by mixture? Mixture also, it's made up of 2 or more substances. Okay, here is just mixing 2 or more substances. Here we didn't mention that they will join chemically. So if you will have a question that it says compare between compound and mixture, so you will say both of them, they contain, or they are made up of 2 or more substances. But in compound, you should mention they join with each other chemically. In mixture, no, they will not join with each other chemically. Both of them, compounds and mixture, we can return it back. How? For example, let's take an example of mixture. Mixture, how we can separate mixtures. So, separation mixtures. We have some ways. The first one, it's what? It's filtration. In mixture, if you have liquid mixed with something solid, this solid, when it will not dissolve in the liquid, So how we can separate them from each other? We can separate them from each other by filtering them. So it's either by filtration, an insoluble solid can be separated from a liquid by filtration. Another way, which is here soluble substance and its solvent can be separated by distillation. Okay, and here you have the way. Here, as you can see, we have some ways we will use it to separate mixtures from each other. Here, this way it shows the filtration, and this way it shows the distillation. Check your understanding. This again, it will be your task. So, dear students, that was everything for Unit 7. I hope everything it was clear. Again, write your name when you will finish watching video. If you have any questions, concerns, or if you have any suggestions, please write it in the comment. Thank you and have a good day.